Dear participants, ladies and gentlemen, welcome to the second track. We're starting with Mr. Daniel.
Okay. Everybody hear me? Fine. Good morning. It's great being here. I was just telling everybody it's actually my first time in Istanbul proper. I usually fly through Ataturk Airport, but I never venture into the city itself. So I'd like to say thanks to the organizers and thanks to you guys for having me. So today we're going to be talking about logs. Well, to be a bit more specific, we're going to be talking about logging a Docker environment. Okay, we're going to be looking into some of the challenges intrinsic in a Dockerized environment. We're going to take a look at some of the solutions we can use to overcome these challenges. Specifically, we'll be looking at using the ELK stack, or as it's been renamed these days, the Elastic Stack, Elasticsearch, Logstash, Kibana, and a bunch of other components. And we'll also see a touch of machine learning to complement the ELK stack. Okay, good. So I'd like to start with a true story. Anybody recognize what this is? SKB rides the rockets. I'll give you a clue, it's not the name of a new Disney movie. Anybody? Okay, this is a Linux kernel bug, specifically Debian 6. It results in packet loss. Okay? There's also a huge headache for our development team. For over a week, couldn't understand why some of our customers kept on complaining about connectivity issues with one of our services. Until they finally came across this log message. Now take a close look at this log message. It's not very descriptive, is it? No meaningful description of what's going on, no mention of an error, bug, crash, anything. So the big question is how, in a production environment producing millions of log messages a day, how did our team finally come across this log message and how did they finally troubleshoot the issue? And the answer is using a combination of both the ELK stack, centralized logging with the ELK stack, and some machine learning. If I do my job correctly, you guys will understand at the end of this talk at least the potential of using this combination in logging a distributed environment. So my name's Daniel. I'm an evangelist at Logs.io. If you've no idea what an evangelist is, don't worry about it. You're not alone. Basically, I get paid to talk and write about interesting topics, such as Docker, DevOps, AWS, etc. Got a couple of professional sins. One of them is I like to organize stuff, so I'm organized a couple of meetups back home, and I'm also a DevOps Days organizer in Tel Aviv. My second professional sin is Twitter. I admit it. I virtually live on Twitter, so if you guys are still impressed by what I'm saying, feel free to follow me here. And yes, there's a story behind the handle. Whoever's interested, you're more than welcome to hit me later on, and I'll give you the whole spiel. 1 minute, I promise, on Logs.io. We're a log analysis company, and we provide the ELK stack as an end-to-end service on the cloud. As part of the service, we take care of the entire logging ingestion pipeline, collecting the logs from our users, from the different data sources, processing these logs, parsing them, indexing them, securing them, etc. Okay, on top of the open source ELK stack, we provide a bunch of enterprise class features that are missing in the open source world: built-in alerting mechanism, authentication, authorization, livetail, a bunch of other stuff. And on top of everything, there's an element of artificial intelligence, and hopefully we'll have time to see a bit of that later on. So what are we going to talking about? So I'm going to bore you with some logging definitions, what logs are, why we need them. We're going to take a look at some of the challenges built into Docker, challenges in logging a distributed environment like Docker. We're going to take a look at some of the solutions most of us here might be using. We're going to take a look at how the ELK stack helps us deal with these challenges. And then, like I said, we're going to take a look at machine learning to see how this complements centralized logging using the Haystack. Hopefully we'll have time for some questions at the end, short demo as well. Right, so let's get started. What are logs? Yeah, I can see the rolling eyes here. Anybody wondered about this philosophical question before? No. All right, so if we Google it, it's what we usually do when we have no idea what we can see a couple of interesting answers here. Okay, so the first answer here is not exactly spot on. So no, in the context of development, logs are not pieces of wood. But the second answer here is getting closer to the mark. All right, so like an airplane's log, like a ship's log, logs in the context of development at least, are streams of aggregated and time-ordered events collected from the output of running processes in our environment. And like a ship's log, like an airplane's log, when our container crashes, when our application crashes, the first place we're going to look at are these logs. Why? Because if they're structured correctly, they'll contain a bunch of wealth of information about what happened, why it happened, and when it happened. And maybe more importantly, whose fault it is and who we can blame. And these are the famous 5 W's that people talk about in the context of logs, when people theorize about logs. And yes, you'd be surprised, people do theorize about logs. So, in today's environments, anything with software on it generates logs. Okay, it's not just our applications, it's not just our services. It's any device with software on it. It could be sensors and routers and servers, microwaves, smart TVs. My brother bought a drone a couple of months ago, similar to the drone that the guys from Exeter Labs were offering. You wouldn't believe the amount of log data this thing generates. Okay, so of course, as developers, we'll be using logs mainly for development, for troubleshooting our application, for monitoring them in production, etc. But the truth is that there's a growing amount of use cases for using logs, and companies are adopting logs across the different teams, okay, as their big data, as their data backbone. So you see companies using logs not just for development, but also for security and compliance, for IoT analysis, for BI, even marketing, okay? Other use cases I've seen, customer success, support teams, all right? So in the context of Docker, what should we and what can we be logging? So on the first level, okay, we'll have logs coming from the actual application, the actual services, okay? Typically, these kind of logs, they'll have some kind of timestamp, some kind of severity indication telling us how severe the event is, some kind of identifier to the service, okay, and a meaningful message helping tell us what's going on. In this case, this is a log message from one of the logs.io services. In this case, it's a service that's in charge of collecting the data from our customers. Okay, we call these listener services. And we've got an appender basically reporting that it just cleaned up after itself. A second type of application-specific log data that we can collect from our services, from our containers, are metrics. This depends, of course, on the type of service. But in this case, for example, we're seeing that same listener service telling us that a specific customer sent us a specific amount of data. Now, on a third level, of course, we've got metrics, okay, performance statistics that we can gather from our Docker environment, stuff like memory usage, CPU usage, network usage, etc. And taken together, these 3 different levels can give us a nice holistic view of how our applications are performing. Now, of course, if it was that easy, I wouldn't be here, nor would my company be in business. So let's take a look at some of the challenges that we were talking about specific to Dockerized environments. So we've got to remember that in essence, containers are stateless. Okay? Containers are always on the move, they're transient. All right? At any given time, you can stop a container, you can restart it, you can remove it, meaning that it makes it extremely difficult to persist any kind of logging architecture. All right? I think the last Datadog container survey that I read mentioned 2.5 days as the average lifespan for a container. Is that enough for troubleshooting? Perhaps in development environments, but in production, no way. Okay? So this transiency is challenge number 1. You've got to remember, of course, that containers are also independent, totally unaware of the general deployment context. In fact, the only piece in your architecture that's aware of the deployment context is the execution environment. Okay? Containers, for example, they don't know in what namespace they're running, nor should they know. All right? But it makes it very hard when we try to correlate events across different data sources without that context to understand and write the story and connect the points together. Containers, we're talking about a highly distributed environment. At any given time, you'll most likely be logging from a number of Docker hosts, a number of Docker containers, each relevant for the story you're trying to identify. Okay? Take simple example, lamp stack. Anybody here know what the lamp stack is? All right, some. So you'll have one container running Apache, another one MySQL, the other one PHP. But to be able to connect the dots, you need to somehow tap into all of these data sources. And this distribution is not just horizontal, it's also vertical with different layers of information that you can collect from each container and each host. So for example, we all know the Docker logs command, Docker logs, container ID, etc. And we get the stdr and stdout output for the container. Great. Docker stats command, Docker stats, container ID, and you get all those performance metrics that I mentioned before. Fantastic. Docker daemon also tracks and records data. So any action you perform with your containers is logged by the Docker engine with useful information. Attach, kill, etc. All of these events are recorded and taken together. These three types, these three layers of information, again, can give you a great view of how your containers are performing. Now, what we've got to remember here is the sheer amount of data that's involved, all right? So take the logs.io environment, for example, talking about over 200 Docker hosts, each running multiple containers. Okay, just try and ingest that information a second. Just think about how many data sources are involved. Think about the volumes of data involved. And of course, this is without mentioning other challenges that are typical, not just to a Dockerized environment. Topics like, issues like different formats. Okay, each application, each framework, each system generates logs in different formats. The best example is the timestamp field. Last time I checked, the timestamp field had over 100 different ways of being formatted, and it makes it very, very difficult when you're trying to, again, connect the dots if you have each log built differently. Accessing the different data points, multi-line logs, etc. So I think you're getting the general gist of it here. All right? So all of this creates a simple lesson, which is logging today, despite all the fancy tools out there, and there's some great logging and monitoring tools out there, logging today is a highly time-consuming task. Okay? And in fact, instead of what we'd like it to be, which is a science, it's an art. Okay? An art, whether ugly or not, you decide, but an art it is. So it's not all doom and gloom, of course. There are some solutions out there. Most of us here might be using some of these solutions, so let's just take a brief overview of some of these solutions. So we've got data volumes, all right? Data volumes allow us to map a directory within a container to a local directory. We can even map multiple containers to the same local directory, and this helps us build some kind of semblance of centralized logging, if you like. It helps us persist the logging data that we said is very difficult to persist. The problems start to arise when you start moving containers from host to host. And of course, you've got to remember as well that we're still missing that bit of enhancing these logs, okay? Giving them context. We're not processing these logs, all right? We're just persisting the data. Another solution, another popular solution when we talk about Docker are logging forwarders. A bunch of these around. We'll talk about Spout later on. Spout is one of these logging routers or forwarders. These will run within your Docker host. They'll attach themselves to all the containers, and they'll output the stdr and stdout output of your containers to a defined endpoint. Okay? You still need to configure that endpoint. You still need to configure processing and enhancing the logs. And again, we're only talking about one layer of information from your Docker environment. We're only talking about the Docker logs here. Logging drivers. Okay, logging drivers are great built-in functionality. Why am I keep on doing noise here? No idea. Great built-in functionality added to Docker version 1.12, I think. And what they allow us, when running a container, we specify a supported logging driver endpoint. This could be AWS CloudWatch, it could be Splunk, it could be FluentD, it could be Graylog if I'm not mistaken. A bunch of these drivers are also easy to use, relatively easy to use, but again, we're encountering that issue of configuration of that endpoint, of enhancing and processing the logs. And again, we're only talking about one layer of information, only Docker logs. And of course, there's a bunch of paid solutions you guys can use, including the one yours truly works for. So Datadog and Papertrail, etc. Easy to use. You'll get around-the-clock support. You've got to remember, of course, that as your data grows, and your data will grow, okay, these will come at a cost. So it's something you've got to keep in mind. So you might have noticed that all of the aforementioned solutions aren't perfect. None of these solutions will answer all your needs, and some of us might be combining some of them together. Okay? But the truth is that more and more developers, more and more companies, more and more DevOps organizations are moving towards a more centralized approach using centralized logging. Why? Okay? Because centralized logging allows you to detach the logging architecture from your containers. And it allows you to do this by giving you the tools to collect the data from all the different distributed data sources, from all your containers, from all your hosts, store it in one central point. It'll give you the tools to enhance these logs, okay? Process them, give them that context that we said we need to be able to effectively correlate events, and also give you some analysis tools, okay, to query the data and visualize it. Maybe when we try to think about the effectiveness of using centralized logging, let's take a look at how logging was done in the old days. So we used to SSH into a machine, perform some kind of fancy grep, and then scan the results, and hopefully you'll come across that one log message that is crashing your application. Well, good luck with that, okay, in an environment like the one I described before with hundreds of instances. So in the new school logging, all you do is access Kibana. Okay, so it's not that simple. Of course it's not that simple. Nothing is ever that simple, but that in essence is the benefit of using centralized logging, and hopefully we'll see a bit more of this later on. So when people talk about centralized logging these days, especially in the world of open source, they're talking about the ELK stack, or like I said, it's been renamed these days as the Elastic stack. Okay, Elasticsearch, Logstash, Kibana, that's the backbone of the stack. Talking about the world's most popular open source log analysis platform these days. In fact, you know what? It's probably the world's most popular log analysis platform, forget open source. Used primarily for log analysis, but also as search, for search infrastructures, for websites. And also, like I said, increasingly more and more use cases. BI, SEO, etc. Just some statistics to help put things into proportion. So Elasticsearch is the second most downloaded open source technology out there. Anybody know what number one is? Guesses, come on, wake up.
Linux.
Sorry?
Linux.
Linux, very good. Elasticsearch is also the second most pulled Docker image on the Docker Hub. Again, number one is Nginx. All right, we're talking about a total of over 100 million downloads for the entire for the different components of the stack since 2012. Okay, so these are impressive numbers by any account. And I also like to use this slide to to give us the proportion. So if we did like an overview of the logging industry, we'll see about 15,000 companies using proprietary tools like Splunk, Sumo Logic, etc. Great tools, but when compared to the ELK stack, we're talking about a drop in the sea. And this is statistics from the companies themselves that they report. Why is ELK so popular? Well, for all the main reasons, we like to use open source tools, all right? Got a huge community driving it. Very popular, got updates driven by the community, and of course it's free. Second, it's relatively easy to use, all right? Any developer can get it up and running within a couple of minutes. Starts to get a bit complicated as you start to scale up and your data grows, but in essence, to get started, relatively easy and simple. And it's fast. We're talking about blazing fast results when you're searching across millions of documents, okay? So what does a classic ELK stack pipeline look like? So at the heart of the stack, you'll have Elasticsearch. Elasticsearch is the stack's data store, if you like. Okay, this is where you store all the data. It's a full text search and analysis engine based on Apache you've seen. Fully open source, of course, boasts an extensive REST API, so you can easily integrate with the data and query it. So this is where your Docker logging data and metrics, etc., will reside. Collecting the data from your different data sources, enhancing it, processing it as Logstash. I guess you could call Logstash the stack's workhorse. It does a lot of work in aggregating the data and processing it. That's why Logstash is renowned for a couple of performance issues, all right, you may have heard of. Anybody here experience any Logstash issues? Okay, all right. So Logstash will be pulling the data, processing it, enhancing it, etc., and sending it on to Elasticsearch. And you'll have Kibana, which is basically the stack's pretty face, the UI, to analyze and visualize the data. Now, this is the classic, what the classic pipeline looks like. All right, but there are different variations of it. You could, for example, use a different log shipper, such as FluentD, or any of the beats. The beats are a family of log shippers by Elastic. Elastic's the commercial entity driving the stack. And you can also use some kind of buffering mechanism, all right, queuing in front of Elasticsearch to make sure data is not lost in case of service downtime. But again, this is the classic pipeline that you'll most likely be using some kind of variation of it. So, all right, how do we put all of this together? Well, the truth is that installing the stack, getting a pipeline of logs is a topic for an entire workshop, but I will provide some getting started steps for those of you who are just starting out. Obviously, the first step is to install the stack. Bunch of ways to do this. I recommend using this Docker image. It's by far the most popular Docker image for the stack. Last time I checked was about 100,000 pulls on the Docker Hub. Great documentation, rich running options. You use Docker Compose, and you've got 3 parallel containers running for each of the components. Elasticsearch, Logstash, and Kibana. You'll have port forwarding mapped for you, and you'll have a data volume for persisting the Elasticsearch data. Okay, so great way to install the stack. That's the easy part. Now it starts to get a bit complicated, all right? How do you get the logs from your containers into the stack? Okay, so again, bunch of ways to do this. It all depends on how you set it up. So we've got to remember that containers, by default, are outputting logs to a JSON file. This is the JSON file logging driver, so to speak. So one way of getting these JSON files into the stack would be using FileBeat. FileBeat today is becoming the de facto log shipper for the stack, even replacing Logstash in some way. It's also the log shipper that Elastic themselves are pushing these days. It's a lightweight shipper, okay? Supports encryption, written in Go. And what it does in essence is it tracks specific files that you define the paths to, and it will ship them into, well, whatever destination output that you define. 2 main configuration sections in your FileBeat configuration file. One are the prospectors. These are basically where you define the location of your container JSON files. By the way, if you're looking for these files, they're located on your host under Docker var lib, something like. Ask me later. I can't remember the exact path. So this is where you'll define the path to these logs. And the second section is where you're pushing the logs to. You could do this directly into Elasticsearch container. Okay, but in most cases, you're going to ship them into Logstash for processing and enhancement, and we'll get to that later. So that's one way. Another way is using the logging drivers that I mentioned before. So again, logging drivers allow us to define some kind of third-party endpoint when running our container. In the context of ELKstack, you'll probably want to use the syslog logging driver. So here's an example for running a container and defining the syslog instance. You've got to remember that when you configure Logstash, you'll need to configure the syslog input plugin to correctly accept the logs from this drive. Another way is Logspout. So I mentioned Logspout before. Logspout is a very popular way for shipping only the Docker logs, okay, STD and STD output of your containers to either syslog or Logstash or any of the other supported modules. What it does is it runs as a container within your host. So basically it routes all your container logs into your defined endpoint. This is just an example of running Logspout container and using syslog. All right, so again, because we're using syslog, in your Logstash configuration file, you'll need to define the syslog input plugin. Okay, so those are methods of getting the logs into the ELKstack. Critical stage in your pipeline is configuring Logstash. So again, you could ship directly into Elasticsearch, but without Logstash, you're missing a crucial point here of how to parse these logs. Okay, how to give them that context we said we need when logging in a distributed environment like Docker. So in Logstash, 3 main configuration sections in your Logstash configuration file, where you're inputting the logs from. Okay, in this case, we've got the syslog input plugin, but there's over 100 different input plugins that you can use. If you're using FileBeat, for example, you'd use the Beats input plugin. The third section is where you're pushing the logs to, in this case, the Elasticsearch container. And in the middle section, the filter section, this is where Logstash's magic happens. All right, this is where you really massage the data. This is where you parse it. You define what fields you want to lose, what fields you want to add, how you want to map the different fields in your log. Okay, this is an example of a grok filter. The grok filter is probably the most commonly used filter plugin in Logstash. What it allows you to do is use regex-based syntax to map the different fields in your log. Grok is a pain in the you-know-what. Not easy to use. I highly recommend using a tool called the Grok Debugger. It's a free online tool where you can play around with your Grok filters, and it'll help you experiment before you start Logstash. I've got to touch upon the issue of security here. So I'm not sure if you guys heard about this, but about half a year ago or even more, thousands of Elasticsearch, insecure Elasticsearch clusters on AWS were hacked by this ransomware attack. So anybody with one of these clusters trying to query Elasticsearch got this ransomware message. Not pleasant. Last week, another security firm published a list of over 4,000 clusters on AWS that were insecure. All right. The good news is that there's some easy steps to do, even if you're just setting up a small development environment to secure Elasticsearch. First and primarily, all you have to do is bind Elasticsearch to either localhost or private IP. It's that simple. Okay. There's a network host directive in your Elasticsearch configuration file. Step number 1, and you should be all right. Of course, you can change the default ports. Use some kind of proxy, add authentication, authorization in front of Kibana, etc. You should be all right. And that's about it. All that's left to do is analyze and visualize the data. Now, the truth of the matter is that this only deals with one aspect of the challenge. Okay? You've got to remember that result of establishing a logging pipeline from your Docker environment result, even in a medium or small-sized environment, results in thousands and thousands of log messages. So we've got Kibana. Okay? Kibana will let us query the data. But that's great if we know what questions to ask, right? But in most cases, and we can all admit it here, we don't know what questions to ask in the first place. And this is the classic needle in the haystack syndrome. All right? How do you find within a shit ton of data, excuse the French, how do you find that one log message that's really crashing your service or really crashing your application? Okay? And this is where machine learning comes into the picture. Now, let's face this right on. Machine learning and all the related topics, AI, deep learning, machine understanding, all of these terms are being thrown away way too many times. All right? But even buzzwords at some stage stop being buzzwords. Okay, let me remind you, I've been talking about Docker for about, what, 20 minutes now? Docker 2-3 years ago could also have been considered a buzzword, and look at Docker now. All right, so the truth of the matter is that machine learning today is already being implemented by companies as part of their technology stack. And in the context of big data, in the context of logging, what machine learning can help us do is sift through these large amounts of logs coming in, okay, and ask those questions that we said we don't know how to ask in the first place. So what I'd like to do is do a short demo. So what you're looking at now is the Logs.io UI. If any of you are using Kibana 5, anybody using Kibana 5? You'll see the resemblance. It's basically the same UI, just with some added stuff. In this case, I'm using a Docker log collector that we created. It acts like log Spout. Okay, the only difference is that it wraps 4 different Docker APIs to ship not only Docker logs, but also Docker stats and Docker daemon events. So what I'm going to do is open a saved search to show only Docker logs. So if you guys were using any of the methods I described before to ship your logs from your containers into the ELK stack, this is what they'd look like. On the left, you've got the list of fields as they've been mapped by Logstash as the parsing took place. So what you do is you just add some of these fields to get some visibility into the logs. So container name, perhaps host ID, etc. And then what we do usually is just enter some kind of query to look for specific pieces of information that we're interested in. Of course, Kibana is more famous for its visualization capabilities. So for example, I could just click this visualize button, and then I get this, well, not very useful bar chart showing the different logs coming in from the different containers. But you can, of course, slice and dice the information any way you want, using any of the visualizations that Kibana supports. So for example, create some kind of overtime histogram, giving us a depiction of the different logs coming in. Okay, and then once you've got all your visualizations ready, you put them into some comprehensive dashboard, right? And this is really what people talk about when they talk about using the ELK stack, all right? This ability to give you that holistic view of what's happening in your Docker environment. So I'm going to go back to the main Discover tab. Let's take a look further back in time. Let's look at the past week, for example. And we can see here almost 400,000 log messages. For a week, that's not a lot, but it should be enough to convey the message here. So again, the question is, how do we find relevant information? All right? We can see that one of these buckets here, representing the logs coming into you. So one of these columns is colored, and underneath we have a list of some events. We call them insights. I'm just going to click one of these events or insights, and all those 400,000 messages are filtered. I'm going to open one of these log messages, and what I get is a description of what happened, and some advice on how to counter what's happening, and then I get a link to Stack Overflow, to a discussion on this very same log message. Now, it's important to understand that behind the scenes, okay, what is happening here is basically machine learning model identified some kind of correlation between log data, okay, and labels that we train the system to identify. So, hopping back to the talk. So how does one even go about starting to implement this kind of combination between logging and machine learning? So on a very high level, different categories of machine learning. There's supervised machine learning, unsupervised machine learning, and some other types. The model used here is supervised machine learning. What we're doing in supervised machine learning, we're feeding model with samples, and we're giving the model the correct answers to these samples. And we expect that at the end of this process, the model will be able to give us the right answer to samples that it hasn't seen before. Okay, that in essence is what we're doing in supervised machine learning. And in the context of logging, what we're doing is we're feeding the system with log messages as our samples, giving it the correct answers to these log messages. And what we want it to do is answer one simple question. Is this log message important? Do we need to take a look at this log message? How do we do it? Two main steps. First, we need to collect these samples, and we need to label them. So collecting them is easy for a company like Logsair, because that's what we do. We collect logs from our customers. The labeling is a bit more complex. In the labeling process, what we're doing is we're defining a set of features, and we're attributing these features to the log messages. Examples for these kind of features could be a log message containing specific syntax. So if you identify a log message with the word error, that gets a label. Another example could be a log message opened more than 30 times. Okay, we can identify this, give it a label. And then we're going to use these labels to train a classifier. Classifier is basically a mathematical formula, mathematical representation based on these labels, and it's supposed to give us the answer to that crucial question, whether log is important or not. On the architecture side of things, we're talking about a lot of computing power needed here. We have over 50 different EMR instances running on Amazon to do this computation. Hadoop, Spout doing a lot of the heavy lifting. So let's circle back to our Disney movie. So I think you all can already guess the answer to the question that I started the talk with. How did our team finally come across this log message? And the answer is by applying this machine learning model. Okay, a correlation was identified with this discussion on server fault. Okay, and it was a matter of a couple of hours to resolution. So this is the potential of this combination of using centralized logging with the ELK and a machine learning model. Time for some summaries. So when people ask me what's the best way to log a Dockerized environment, I usually smile. Not because I'm trying to be funny, not because I'm trying to be cruel, simply because there is no out-of-the-box solution. There's no silver bullet, so to speak. It all depends on our needs, on our requirements. Do we want to, are we interested only in our Docker logs? Do you want to also take a look at our metrics, Docker stats? Are we willing to go for a paid solution? Okay, so it seems to me until Docker itself. Anybody here from Docker by mistake? No? Okay. So it seems to me that until Docker itself doesn't take logging to a tiny different level, it's up to us to hack a solution. We talked about two main challenges involved in logging a Docker-based environment. One is collecting the data from the different data sources, giving the logs context, okay, enhancing them so we can easily correlate events across the different distributed data sources. And challenge number two is actually gaining some insight from the data. So while the ELK stack is perfectly poised, with all its challenges, perfectly poised to tackle challenge number one, it's challenge number two that we're going to look increasingly at machine learning to answer that question. And we can already see, like I said, companies applying these models to overcome this challenge. Just a few extras before I end. We've got some great resources on our blog, on the Logs.io blog, not just about Docker, not just about the ELK stack, but also about other related topics, DevOps, AWS, etc. Elastic documentation is a great resource to use when playing around with the ELK stack. Okay. Also in the context of Docker. We've got a Slack team that we opened for ELK users, for ELK users. So if anybody here has any questions, any stories he wants to share, any lessons, feel free to join the discussion, and create a more active community there on Slack. That's about it, guys.